Hello everybody, this is Chris with Overclockersclub. I got two coolers from Noctua today. We've got the NH-L12S and the NH-U12A, and you can see by the size difference in the boxes, they're very different coolers. So we need to open the boxes and see what's inside. So we'll take a look at the larger cooler, the NH-U12A first. I will say this, every Noctua cooler I've ever gotten, it's a real experience just going through the way they package their stuff. Nobody, and I mean nobody, packages their stuff the way Noctua does. It's like getting a new BMW or a new Audi. The quality and the engineering and the time that goes into making sure that all of this packaging fits is absolutely amazing. Probably better if there we go, it's going to come out a little easier. I've just never seen any other manufacturer put so much effort into their packaging. So here's the accessory box, and there are always all kinds of goodies in here. Of course, on the top you always get a visual indication of what's inside. So we have our various installation instructions here for our AMD and Intel sockets. We have a little pack here that has our thermal paste, our different splitters, little Noctua solid little emblem there you can stick on your case. I'll show you that here a little later. You always get this nice screwdriver for installation. And then we have the various brackets here that attach to your socket, whether you have an Intel or an AMD unit, and there's your base bracket there for some of your Intel sockets. But that's the hardware kit. And then looking at the actual cooler, sometimes it takes a little bit of work to get them out of there because they're packed so well. I think you could drop this thing off of a skyscraper and it wouldn't be damaged. There we go. So here we go. This is the NH-U12A. We got two 120 millimeter fans there. Looking at the bottom, at this little plastic cover that protects this base plate, and that is polished pretty much to a mirror finish. You can just barely see the machining marks in there. And then when we look at the number of heat pipes, I don't think you could possibly pack any more in there. You've got 1, 2, 3, 4, 5, 6, 7 heat pipes that snake their way up on either side of the fin stack there. Get the fans off there. So there you can see the fin stack. And what they've done with these heat pipes, they've alternated them. Instead of putting them all in a row, we have 2 of them, and then we have 3, and then we have 2 more. So what that does is that really exposes the heat pipes to the airflow that's being moved through the fin stack. So you maximize your heat transfer from the fin stack to the air that's moving through. So there's some real engineering that goes into these. I've always been a big fan of Noctua's method for attaching the cooler to the motherboard. The retained fasteners there that are spring-loaded, they ensure that you get just the right amount of pressure to hold that cooler down to your motherboard. And then if we look at this a little more carefully, the other thing I notice is it's actually offset. Your base plate here is actually a little closer to one side, which should aid in RAM clearance. And then we have these 2 fans, and these are the NFA 12 by 25 millimeter thick, so about an inch thick. and they are 2000 RPM. They draw 0.14 amp, and they use 1.68 watts. So all that information is printed on there. So the NH-U12 series has been around since 2005, so there's been plenty of time for Noctua to really perfect the design. So we've got a high fin density with all of those heat pipes that are exposed to the airstream. And these heat pipes are actually soldered in place. Sometimes they're pressed in from some manufacturers, and with thermal expansion rates being different between different materials, they have the potential to loosen up. But not with this one. Since these are all soldered in place, they can't go anywhere. You get the maximum amount of contact area between the heat pipe and the base plate there. Now, as far as RAM compatibility goes, you've got compatibility with your AM4 motherboards and your base Intel motherboards for your LGA sockets. But on your LGA 2066, the rear fan will overhang one bank of sockets, so you just want to make sure that you don't go any higher than 42 millimeters on your RAM. Overall height, so if you're putting this in your system, your case height you want to watch, because you are limited to 158 millimeters. So you should be okay with most cases, but if you have a shallow case, you'll want to know that before you put this in and you try to put the cover over it, and it won't fit. Now, if you have some older legacy sockets like the LGA 1366 or 775, you can talk to Noctua and they will send you a free mounting kit with the special hardware for that. So that's nice. And you get an almost unheard of 6-year warranty, which is pretty typical for Noctua products. So now it's time to go ahead and get the cooler assembled to the test motherboard here. And I have previously reviewed these little guys here. These are the NASCW1 cleaning wipes. Good time to use them is when you're putting a system together and you got to clean the old thermal paste off there. So we'll just go ahead and open one of these up. Actually, oh, here we go. It's got a little tab there. There we go. I reviewed these in a previous review, but it's a pre-moistened cleaning wipe. It has some detergent on there. It's made specifically to get rid of old thermal paste, and it does a remarkable job of cutting through the old paste and not leave any residue on top of your CPU. So now we are ready to get the bracketry on there. So I made this little motherboard tray specifically high enough so you can get in there, and then I made the cutout big enough so we can get the bracket on there, which that fits in there just fine. And then we have the rest of the hardware. So I'll drop back down through there for the moment. And then we'll get all of these little pieces. So I know from previous experience which hardware goes with this particular socket, which is pretty common with the Noctua coolers. So we'll just get one started, and then these are the brackets here. Now these will attach to the bottom mount. They can either go on this way or that way, so depending upon which way your cooler mounts, you need to look at these two mounting fasteners. And since I want the cooler to sit on there in this orientation, since the air will be going this direction, I need to make sure that these pieces then would sit on there like that. So we'll go ahead and push that bracket up from the bottom. that, hang on to it, and then we can get one of these started. And they have 3 little holes on each end that are for specific sockets, and those are called out in the manual on which set of holes you want to use. For this particular socket, it's the center set. So you can see how that would fit. And then we put these little spacers on there. So one goes on each side. And that spaces the bracket up to the right position. And then we can go ahead and get that locked down. So we have the other 3 fasteners locked down. I got the spacers under there. You don't want to forget those. And now I kind of do a real rough test fit just to see how things go. And you got to keep in mind that the fin stack here is actually biased to one side. It's offset a little bit. So you want to make sure you're going in the right direction. So if we put it here with the bias toward the ram sockets, when you go to put your fan on, you're going to have some issues. Let's see, make sure you use the right fan there. Okay, so this fan, I want to push the air that direction, so the back of the case would be over here. So if we put it in this orientation, you can see the fan is going to overhang the ram slot. So unless you have really low profile ram, it's better to actually flip this around so the bias is to the other side. Now I have plenty of room over here, so when we put a fan in that position, we clear all the ram slots, and there's still room on the back side here for the other fan. And it hangs without hitting anything. And you want to watch your fans too. The brackets can go on either way, but when you take it out of the box, one of these fans is meant to move air that way. So the brackets are on one side and the other fan has the brackets on the other, so you can have a push-pull configuration. You don't want to put the brackets both on the same side of the fan, because then they'll be fighting each other. They'll either both be trying to suck the air out or push the air in, which of course won't work. So now we'll go ahead and tighten the fasteners. They are spring-loaded, so you have to push down a little bit to get that screw to bite. And you want to be careful that your screwdriver doesn't slip, because you really don't want the screwdriver to go skidding across the surface of the motherboard. So the key there is just take your time. I know it's exciting. Sometimes you're putting a new system together, you're anxious to get it going, but you really want to take your time. And I alternate back and forth between the 2 sides, and you can feel when the screw bottoms out, you're done. A few more turns here and we should be good. There. That side's done, and now this side right there. Okay. Time to get the fans on. So the fan comes with this splitter here. And basically this end plugs into your motherboard CPU fan header on one side there, and then the other ends you have for your 2 case or your cooler fans. So if you want to free up a header, if you're short on fan headers and you want to free one up, you can use this, and that will allow you, instead of plugging both fans directly into the motherboard, you can plug them both into the splitter and only use one header, and it leaves one freed up for a case fan if you'd like. It also comes with these 2 little low noise adapters. They're basically just resistors inside of here that slow the fan down if fan noise is a concern, although I can say all the years I've dealt with Noctua fans, I've never had a problem with what I would call fan noise. Here's another nice accessory. Now I've reviewed these already. These are sold separately. If you want to color coordinate your system, these are black and red. They have black and blue. They have green and black, yellow and black. Several different combinations, and since we've got a black and red theme motherboard, I'm going to go ahead and use these. So we plug that into the CPU fan header right there. Again, you want to pay attention to which side the brackets are on. Now I haven't taken the brackets off, but since this fan direction is that way, and when it spins that way, That means the air is moving out the back. So we want to make sure we put that on the proper side of the cooler, because you don't want the two fans fighting against each other, or you won't move much air. And then this fan here, this side is moving air this direction, so it'll go through the heat sink, and then this fan will help pull it through the back. So this is your push, this is your pull. And then we put this fan on here. The clips go on real easily. And then we're ready to plug these into the header. And it doesn't matter which fan plugs into which socket here. And now we're ready to get the rest of the peripherals attached and put the power to it. The power is on, the fans are spinning, and what I usually do is take a quick look at the idle with no load temperatures, which they should be in the upper 20s to low 30s, which they are. This line right here. And the way to really tell is when we put the heat to it. But at least at idle, things look good. Now, if you saw temperatures here in the upper 30s or into the 40s and there's no load on the system, that might be my first indication either I don't have a fan plugged in, or I don't have the cooler seated, or my thermal paste application needs a little help. But since the temperatures look good at idle, then I will proceed to get some thermal imaging here, and then we'll put the load on it, see what those temperatures look like, and of course get some thermal imaging with that set up also. So we got the thermal camera all fired up. This is the intake side of the cooler. There is no load, so it's at idle. This is about as cool as it's going to get. Come around to the side of the cooler, and it's about 32, 33 at the base, and a little cooler at the top. And then we'll look at the exhaust side here. And again, since we're not under a load, we shouldn't really see a huge difference. And then looking down at the motherboard, right in there, it's a little warmer. And then the back side here, there's the memory right there. Okay, so we see what it looks like at idle. Now let's put some heat to it with a nice overclock and see what it looks like. So now we have the overclock cranked up, 4.2 gigahertz. We've got the Prime 95 stress test rolling, and our temperatures are not too bad, right around 74, 75 C. And let's see what the thermal camera shows. So now we have the overclock on the 4770K cranked up. There's the intake side. Come around and look at the side of the fin stack. Should be the coolest at the top. So around 29, 30, 28, somewhere around there, 31 at the top. And as we look down the fin stack, we should see it get a little warmer. Yeah, a little bit there. And then we'll come over here and look at the exhaust side. There's the VRM at the bottom there, heatsink for that, so you're going to see a hot spot with the overclock. So now I think I'll go ahead and just pull this fan off from the back and see what the fin stack looks like, if we can see the heat signature directly on the fin stack. Alright, now I took the intake fan off, or the front fan I guess you could call it, so we can kind of get an idea of the heat signature on the fin stack, and you can see exactly where the heat pipes are. You can see how the heat is being transferred from the bottom, and it gets cooler as we go up the fin stack. And then if we focus right down there on the base plate, getting a little bit of reflection there off of that metal. But even that is staying in the 30s. 30s there. And since I have removed the back fan, we're only running on one fan, and I want to add, these fans are very quiet. 2000 RPMs, you really don't even notice them. But with that one fan off, I notice the CPU temperature has creeped up to about 77, 78 C under a load with just one fan. So I'm going to put this other fan back on and see how long it takes for the temperature to drop back down. So I have both fans running again, and it took about 2 minutes and the temperature dropped from 78 back down to 75. I saw it even bounce down to 74 again, but it seems to be holding. So clearly the two fans, there you go, there's 74 right there. Clearly the two fans definitely make a difference, and they are, like I said, very quiet. They're cranked all the way up and you really don't even hear them. Now, a little word of advice: anytime you're working on a system, one for example that has metal fan clips, if you're taking fans off and on, you really need to make sure your system is powered down, because these little clips are in there pretty good, but they can still fall off if you're not careful. And if they fall down on the motherboard, just like a screw or a screwdriver or anything like that, you could get a really unhappy 4th of July show with sparks. So always power your system down. Don't ask how I know that when you're working on it. So the testing of the NH-U12A showed me that for a mild overclock and 4.2 gigahertz, at least by today's standards, is really on the mild end. But it can handle the heat, and at 74, 75 C, you've got some room there to go a little higher if you want. So I wouldn't be afraid to let it take on anything you can throw at it. Next, though, we've got the NH-L12S. Now this is a much smaller cooler, and it's a downflow. So it'll be interesting to see how this one can handle the heat. So let's take a look at it next. So we'll get the NH-L12S out of the box, and it's at a completely different end of the spectrum as far as application, because it is much smaller than the cooler here we just looked at, the NH-U12A. So there's the hardware box. Again, it's just like the other cooler as far as having a little pictorial illustration of what's in the box, and your instructions, warranty information, mounting brackets, thermal paste, and it looks like a single, of course there's one fan here, so we have a single low noise adapter, which is really just a resistor that will slow the motor on the fan down enough so that you don't have as much noise. But again, I've never really had an issue with any of the Noctua fans being noisy. So here's the cooler itself. Got a little plastic cover on the bottom of the base to protect it, make sure it doesn't get scratched up. And again, we have all this packaging that is just made to fit like a glove around the product. A lot of engineering and thought goes into that. Get this all out of the way. And here is the cooler. Now you can see it is much smaller than the NH-U12A, but again, this is aimed at a completely different segment where clearance is an issue. You need a low profile cooler, and you're probably not going to be thrashing this with a hard overclock like you would in some systems. So we have 4 heat pipes, the same type of highly machined and polished base there. We use the same type of screw retained fasteners there. There's a little C-clip there on the bottom that keeps the screw attached to the base bracket. And the springs there, again, ensure that we apply the same equal amount of pressure of the base plate here onto the CPU cooler. And then we have some access holes that go straight through it that make it much more convenient to attach it. Now this fan also attaches by the same type of little bracket here on the side. clips pop off, and let's see if we can take a better look at the fan. So here's the NF-A12 by 15 PWM fan. So it has a 4-pin connector there. So it is pulse width modulation, uses 1.56 watts and draws 0.13 amps at 12 volts DC. So it's a very thin, low profile fan. And I'll get the specs up here so we can look at that. So the maximum speed on the fan is 1850 RPMs. When you put the low noise adapter on there, it drops it down to 1400 RPMs. So not a huge drop, but apparently that's enough to reduce the fan noise. Now if we're looking at clearance here, the top of the cooler comes to about 70 millimeters there. And when you have the fan underneath for your low profile mode, so the fan actually attaches underneath here, then all you're really worried about is the height to the top of that fin stack, which is 70 millimeters. But if you want the low clearance mode, which means on the side of your fin stack, if it overlaps your RAM, well, the fan would be in the way, so we put the fan on top. So what that does to the height, looks like it comes in around 85, 86. Get that fan right to the edge. Yeah, it looks like about 86 or so, maybe 87 with those little rubber pads kind of protruding up a little. But that gives you an idea of how much space you've got. And again, this is really for an application where you don't have a lot of clearance and you need the low profile type of cooler. So now we can go ahead and get it swapped out on the motherboard and start looking at some thermal characteristics. So this cooler can actually be mounted in any one of 4 orientations depending upon how you install the original mounting brackets here. So you can have your 2 mount points here, or you can rotate them 90 degrees and have them here, and that'll determine which way you can mount it. And most motherboards are kind of laid out the same depending upon the socket. So you really have to sort of see what makes the most sense as far as clearing your VRM modules, your RAM modules. If you've got a graphics card that's a little close on one side, you'll have to make that determination. Now looking at the back side of the fin stack, there's actually a little recessed area here that sort of grabs the fan there and locates it and holds it. So that's on the back side or the underside of the fin stack there. So that's sort of nice to make sure you get the fan in there aligned properly. So I'm just sort of doing a quick test fit here. I'll clean off the old thermal paste, get some new thermal paste on there, and then I'll figure out which way makes the most sense, and then we'll fire it up. So we have the system powered up now. We're at idle with no load. We're running around 30 degrees Celsius. Nice thing here with a downflow cooler, and I don't have the fan clips on just yet, so the fan's just sitting on there. But we're pushing air down through the cooler, and it is moving out across the motherboard. So you're cooling things like your VRM, your RAM will take advantage of that additional airflow across the motherboard. But what you need to keep in mind, with a cooler like this, the one we just reviewed, the NH-U12A, the 2 fans are moving a lot of air through the cooler and toward the back of the case where it'll be pushed out of the case. A downflow cooler like this one, though, your heat that is being extracted from the fin stack and dumped basically into this volume of air inside the case, you've got to have a case that has good airflow, good circulation through the case. So your intake fan or fans on one end of the case and your exhaust fan or fans on the back side of the case or the top of the case, those really need to do their job and keep the air flowing through the case. So the heat that's being removed by this cooler has a way out. If not, that heat will just build up inside the case, and over time things just get warmer and warmer, especially if you do an overclock or you have a system that's really loaded up. Another thing to mention is that I don't really expect this smaller cooler to really perform the same way as the NH-U12A, because we have almost double the number of heat pipes with this larger cooler. We have a larger fin stack, so we have a lot more mass. And then with the two fans, these are much more powerful fans. They'll move more air than this fan. So I would expect this one to get a little bit warmer on our overclock. So what I'll do next is I'll kind of do some thermal imaging with no fan. We'll let it heat up just a little bit so we can see how the heat travels across. And then we'll crank it up and really see what it looks like. So here's what the fin stack looks like, or the cooler I should say, with the fan sitting on top. And again, we're at idle. I can get this to zoom in there. There we go, across the top of the fin stack. So what I'm going to do is, since I haven't attached the fan yet, I'll just take the fan off and let's see what the fin stack looks like with nothing on it. So you can sort of see where the heat pipes run up through the center there. So we should be a little warmer at the back of the cooler where the heat pipes wrap up and first enter the fin stack. So around 35, 36C there, and it should get cooler as we go toward the opposite end. And it does just a little bit, not much. So now there's no air flowing through it, so this will slowly warm up. Kind of come over here from a different angle. And now we'll put the fan back on. And then we'll crank the heat up and see what things look like. And what I'll also do is I'll take one of these fans from the other cooler, the larger fan, and we'll just set it on top and see what it looks like when we're moving more air through the system. So now we have the overclock cranked up to 4.2 gigahertz. We're sitting around 84C at the CPU temperature. And you can see the fin stack. Now I'm looking at the other side of it here now. It's a little toasty. If we pull the fan out of the way, you definitely see some warmer temperatures. So we'll put that fan back. So that shot me up to 87, just that amount of time taking the fan away. So I am going to put the larger fan on there just to see how it performs. So just for giggles, I went ahead and replaced the stock NFA 12 by 15 with an NFA 12 by 25, which was from the NH-U12A, so the first cooler we tested. So we basically have a larger, thicker fan on there, and it cranks up to 2,000 RPMs as opposed to the roughly 1,800 of the smaller fan. And my temperatures are actually holding about the same 84 degrees C. So even though we have a larger fan that moves more air through there, with the same overclock, we're not really seeing a big difference in the cooling. So that tells me the smaller fan is adequate for this cooler. I'll go ahead and move this fan out of the way and look at the fin stack again. You'll see it slowly start to warm up there. I'll put the fan back so we don't get too hot there. And finally we put the fan underneath so it's drawing air from the top and pushing it out the bottom, so the fan is underneath. And it actually runs 2 to 3 degrees higher. I'm running about 87C at the CPU now. So it would appear that fan placement here does have an effect. We get a little bit cooler when we run the fan on top of the cooler. And we may have some dynamics with the air being recirculated and drawn into the top. And fan placement may factor into that. So anyway, that's what the thermal testing shows. So what I learned about these products in this review is the NH-U12A is a great cooler. It's compact, it's versatile. You can use it for a daily driver, or you can use it for an overclock system. Value-wise, it's about $100. You can find this on Amazon right now, around $100. And you get a really robust heat sink, a couple of great 120 millimeter fans. Again, I don't even know why they include the low noise adapters, because I really didn't see any issues with fan noise at all, even when they're cranked all the way up. On the other end of the spectrum, we have the NH-L12S, the smaller cooler, the downflow cooler. The benefits of downflow, again, are that you are pushing air across your motherboard so you can cool some of those components, but you're really relying on the case for airflow through the case to get that heat out of the case. Now, thermal testing showed that this smaller cooler actually wasn't too bad. We were in the mid to upper 80s, depending upon the fan configuration. But you're probably not going to be buying a cooler like this, and this one's in the $50 range, so it's about half the price of the NH-U12A. But you're probably going to be buying this cooler if you have a low profile case and you just don't have the room for a taller cooler. And you're probably not going to be buying this for a system that you're really going to be overclocking and thrashing on any kind of a regular basis. So again, you get the great top of the line Noctua quality. They cost a little more than some coolers, but you get a 6-year warranty. It's hard to find that sort of coverage. So again, I think either one of these coolers really represent a great value. So this is Chris with Overclockers Club. Thanks for watching, and don't forget to subscribe.